Hey, Phoebe. So I'm going to show you how I would teach this to students in Canada. So this is how we would do it here. The first thing we would do is we would look at the coefficients, so 14 and 56. And we're going to try to find the greatest common factors of 14 and 56. Okay. I'm not sure how you learn to find the greatest common factor there, but I'll show you how we do it here. So the first thing I do is I show all the factors of 14. So I know that one factor of 14 is 1 times 14. I know that another factor of 14 or another set of factors is 2 times 7. So the factors of 14 are 1, 2, 7, and 14. The next thing I'm going to do is I want to find the factors of 56. So the first factor is 1 times 56. The next factor is 2 times 28, because 2 times 28 is 56.
Okay.
The next one, 3 does not go into 56, so it would be 4 times 14. You can check it on a calculator if you don't believe me. And then the last one would be, Fitz?
I have no idea, everyone.
Oh, I hope I'm right. 7 times 8.
Yes, 56, 7 times 8. Yeah, you're right.
So,
Yeah.
anyway, so now, these are all the factors of 56. 1, 2, 4, 7, 8, 14, 28, and 56. I want to find the greatest common factor of those two coefficients. Well, the greatest common factor is 14. It's the biggest factor in both.
In both. Okay.
So now what I'm going to do is I'm going to divide both by 14.
Okay.
Now I want to find the greatest common factor of x squared. Well, the only way to get x squared is x times x, right? X times x,
X.
which is x squared.
Okay.
So the factor, they both have an x squared. So I'm going to divide them both by x squared. Then I'm going to look at y
And Z.
and y.
Oh, wait, sorry.
Sorry, y to the power of 3 and y. Well, for y to the power of 3, the factors are y times y times y. And for that y,
Y times.
it's only y.
Why? Not 2?
Well, there's no number there.
Here, 2.
No, that's a z.
Oh, okay. Okay, I said okay.
Okay, so with the x's, I'm going to go back to the x's. It was x times x, and it was x times x. So the greatest common factor was x squared. With the y's, though, it was y times y times y, but here it was only y. So the greatest common factor would just be the 1y. If there was 2 y's, it would be 2 y's, y2. So I'm going to divide it by y to the power of 1, y to the power of 1. Now, I don't know what they teach you in the Philippines, but in Canada, I teach, we're really lazy as mathematicians. So why write a 1 there if I don't need to? So we don't put a 1 there. The last one I'm looking for the greatest common factor is z and z, or z and z. Well, for this one, z is just z. For that one, z is z.
Yeah.
So I'm going to divide them both by 14 x squared y z, because those are that is the greatest common factor of both of them. So now I have to work my way through each one. So what is 14 divided by 14?
1.
1. Do I need to write a 1?
Yes. No, you don't have to.
I don't have to, because mathematicians are lazy and I have some coefficients.
All right.
So now I have x to the power of 2 divided by x to the power of 2. So I'm going to show you this one here. I won't show them all, but x to the power of 2 divided by x to the power of 2, you learned in a power law, that is the same as 2 minus 2, which equals x to the power of 0. Now, when it's x to the power of 1, that just equals x. But anytime you have something to the power of 0, the answer is always, always, always 1.
Always.
Don't listen to your tita who almost said 0. So really, 14 divided by 14 is, it's 1, right? Times,
Why don't you just put 1?
okay, fine, I'll put it. So 14 divided by 14 is 1, times x squared divided by x squared we said was 1. Now, y to the power of 3 divided by y with no coefficient, without no exponent. So it's y to the power of 3 divided by y. If there's nothing there, it's always what number?
1.
1. So with my power law, because my bases are the same, I can just go y equals 3 minus 1. Remember, anytime those two are the same, if it's dividing, I subtract. If it's multiplying, I add. Don't listen to your tita.
I'm not talking,
So,
baby.
so now it becomes y to the power of 3 divided by y is y squared. So that's times y squared. Z to the power of 1 divided by z to the power of 1 would be the same as, well, let's show it to you. Z to the power of 1 divided by z to the power of 1 is the same as z to the power of 1 minus 1, which is z to the power of 0. As we said earlier, anything to the power of 0 is
1.
always 1. So that's times 1. So 1 times 1 is
1.
1 times y squared. What's 1 times y squared? Now your tita is like sweating here because she's struggling. So here's how I like to think about it. And this is the example I always show my students. Anytime I do 1 times a number. So for example, what's 1 times 5?
5.
5. What's 1 times 10?
10.
What's 1 times 1,000?
1,000.
What's 1 times 1,000,000?
Million.
Let's put our commas in there so we can see it. So anytime I multiply a number by 1, the number doesn't change. So then when I have a
We know that.
coefficient, it's the same thing.
Yeah.
Sorry, not a coefficient, a variable. The variable does not change. So this was 1. 1 times y squared is just y squared. Times 1, it still stays y squared. So all of this equals y squared. But now I got to do that.
God.
So now I'm going to go 56 divided by 14. Well, if I look over here, I already knew 4 times 14 was 56.
Oh.
So that's 4. Oh, I'll do it up here because I'm going to bring it down later. X squared divided by x squared. Remember, we did that right here and we got 1. So it's just 4 times 1. Y to the power of 1 divided by y to the power of 1, or it's just y divided by y. Now here's another thing to think about. What's 10 divided by 10?
1.
1. What's 50 divided by 50?
1.
What's 1,000,000
1.
divided by 1,000,000? So anytime you divide something by itself, the answer is always 1. So y divided by y is just, it's a 1. Or you can use the power law to prove it. But now same thing, z divided by z is 1, or you can use the power law. So it becomes,
What is power law?
power laws are just shortcuts when you're dealing with these powers, these exponents.
Okay.
So Emma this year will just get only into squares. She doesn't have to get into power laws. They get into power laws in grade 9 here in Canada.
Oh, okay.
So now it becomes 4 times 1. What's 4 times 1?
4.
Times 1
4.
times 1.
4.
So it just becomes
4.
y squared plus 4. So that is the remaining factor. Now, earlier, you divided the whole thing. You divided both sides by the same factor. You divided it by 14 x squared yz. Now, anytime we're talking about a factor, we're talking about multiplication, or it can be division. But in this case, we broke it down because we divided. So because we broke it down or divided, we have to multiply to put it back together again, kind of. So we take our greatest common factor, which was 14x squared yz. That was this one right here. And it was also that one right there because you had to divide by the same. So you have your greatest common factor, and if you multiply it by what was left over when we did all the math, y squared plus 4. So now if I had to put it into this table, the common multiple factor, the greatest common multiple factor, if I had,
14.
would be 14 x squared y z.
Oh.
That would be the great or the common factor, the greatest common blah 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 blah. Now, the remaining factor is going to be what was left over when I divided. So that becomes y squared plus 4. Okay? And now the factored form, the answer is my 14
Where is it?
x squared yz, sorry if it's messy, times y squared plus 4. So I don't know if this makes any sense to you. I hope it does. What I'm going to do is I'm going to have your Tita stop the video. She'll send this to your mom. Hopefully it's not too long. And then I'm going to show you how to do this question. So hopefully after I show you how to do 2 of them, hopefully you can then do the next 3.
Okay, that's why I hate school. My God.